Okay, now let's take a look at example 13. A 1.5 kg sphere is dropped from a height of 30 cm onto a spring of spring constant K is equal to 2000 Newton per meter. After the block hits the spring experiences maximum compression X as shown in the figure. First question, describe the energy conversion occur after the sphere is dropped onto the spring until the spring experiences maximum compression. Second one, calculate the speed of the sphere just before it strikes the spring. And last one, determine the maximum compression X. Okay, so we are given a figure here where we have a sphere and also a spring. Okay, so first step, as what we usually do, we always define the system, meaning that we identify what are the objects involved. So we have a sphere with the mass of 1.5 kg, and then we have a spring here. Okay, so now obviously kalau ada spring akan ada elastic potential energy. So kalau ada sphere with the height, we have potential, gravitational potential energy, and also since it will be moving, okay, apabila dia di-release, dia akan jatuh ke bawah dan menyebabkan spring ni untuk compress. So obviously it's moving, it will have kinetic energy. Okay, so now, okay, kita sudah define system, maksudnya kita ada sphere, kita ada spring. Okay, so next step, we need to redraw the figure. Okay, sebab figure dekat sini ada before and after saja. Tapi kita mau lebih nampak dia punya proses, semasa proses ni kan. We want to see it clearly. So Miss pun lukislah the diagram here where I add another situation in between here. What happened in between? Okay, so initially mass tu dia dekat sini kan, which is 0.3 meter di atas spring. So spring ni dia tiada compression, dia tiada extension. So tidak akan ada potential energy dekat sini lah untuk spring. Okay, selepas sphere ni dijatuhkan, because it says here the sphere is dropped from a height of 30 cm. So dia pun kena release daripada height 0.3 meter ni. So dia akan sampai dekat permukaan spring ni. Lepas dia sampai, kita tahu dia akan menyebabkan spring ni untuk experience maximum compression. Okay, so ada 3 situasi dekat sini untuk kita lebih senang tengok berbanding kalau kita hanya tengok before and after here. Okay, so at each situation, let's identify what are the energy involved. Okay, so first, because the keyword here, okay, keyword dekat sini, the sphere is dropped, meaning that dia dilepaskan dalam keadaan velocity sama dengan kosong. So here I can say the velocity is equal to 0. So if the velocity is equal to 0, kinetic energy is also equal to 0, no kinetic energy. And this one, we have a height here, 0.3 meter. Okay, before we can identify whether does it involve the gravitational potential energy or not, kita kena define. Okay, remember I forgot one step. We need to define where is the location where we have H sama dengan kosong dan juga X sama dengan kosong. So X ni apabila kita ada spring lah. So obviously we have spring, we need to select the location as well. Okay, yang paling senang untuk H sama dengan kosong, misalkan select this position here. Okay, position di atas spring ni, H sama dengan kosong, X pun sama dengan kosong. Okay, kenapa kita pilih H sama dengan kosong? Okay, nanti kita akan tengok. Actually, kalau kita pilih H sama dengan kosong dekat sini, mathematics dia lebih simple berbanding kalau kita pilih dekat sini H sama dengan kosong. Dan X sama dengan kosong dekat sini because at this point, there is no compression of the spring, no extension, so dia dekat sistem dia sangat sama dengan kosong dan no potential energy. So lebih senang dekat sini lah berbanding kita letak di sini. Okay. So selepas tu, now that we select the location, okay, we can identify lah. So since the sphere is 0.3 from the position here, so there will be a gravitational potential energy. So kita letaklah dekat sini H1. And then the spring is at the position X sama dengan kosong. So no elastic potential energy. Okay, so the second one. So since dia akan dijatuhkan with certain velocity, right? So at this point there will be velocity sebab dia tidak stop dekat sini. Dia akan keep on moving until this one become maximum compressed. So there is a velocity, meaning that there is a certain value of kinetic energy. And potential energy, since dia ngam-ngam dekat H sama dengan kosong, tiada potential energy. Dan since dia juga di atas spring ni masih dekat kedudukan H sama dengan kosong, okay, elastic potential energy pun tiada. Okay, and now, okay, dia sudah sampai dekat position ni di mana spring ni maximum compression. Dia experience maximum compression. Maksudnya dia tidak boleh compress lagi. Inilah paling maximum dia boleh buat. So this value here, from this point to this point, is the maximum compression with the value of X. Inilah value of X yang soalan mention tadi. Calculate the maximum compression. Lagipun sudah dituliskan dekat sini, dekat dalam figure yang kita dapat. Okay. So kalau ada maximum compression, ada value of X, akan ada elastic potential energy. And then this one is not here, so akan ada value untuk gravitational potential energy juga. And then okay, kita letaklah sini sebagai H3 juga, which means H3 dan X ni adalah value yang sama. So H3, and then at this position, since the spring experience maximum compression, so the sphere will stop. Dia akan stop. Okay, here the sphere will stop. Sebab maximum sudah dia punya compression kan, so it cannot move anymore. So sphere stop, no kinetic energy. Okay, so now this is what we have. So kita sudah identify apa energi yang terlibat. Okay, kita tengok kembali kepada soalan. Apa soalan minta? First question, describe the energy conversion occur after the sphere is dropped onto the spring until the spring experience maximum compression. So apa energy conversion yang terlibat? So since kita sudah buatkan dekat sini, you just tengoklah first. Okay, they have the gravitational potential energy, and then it is converted to kinetic energy, and then next one converted to potential energy and elastic, gravitational potential energy and elastic potential energy. So the energy conversion, so just tulis gravitation, how do I spell this? Gravitational potential energy, so convert to kinetic energy, and then convert to gravitational potential energy and elastic potential energy. So these are the energy conversion. Okay, from the moment it is dropped at this point, and then it arrived at this position, and then this spring experience maximum compression. Okay, so that one is soalan A. Now soalan B. Calculate the speed of the sphere just before it strikes the spring. So just before. So obviously, based on apa yang kita sudah buat tadi kan, ada satu position saja di mana akan ada velocity terlibat. Dekat sini, velocity sama dengan kosong. Dekat sini, sphere tu dia sudah tidak bergerak. So, kinetic energy sama dengan kosong. So, at this point here, we want to know what is the velocity just before it strikes the spring. So, ngam-ngam dia dekat atas permukaan spring. So, we want to find this value for V here. Okay, so we just need to select which one is initial, which one is final. So obviously ni adalah final, ni akan jadi initial. Okay, paling senang lah this one sebagai initial, this one sebagai final. So soalan B, we want to find is value for V. So keluarkan the principle of conservation of energy, di mana initial, sum of initial energies is equal to sum of final energy. So initial kita dekat sini, kita akan pilih position 1, initial, which kita hanya ada this energy, dan final, this energy. So just masukkan UG is equal to K, which is kinetic energy, and then masukkan MGH1 equal to MV square. Okay, so now masukkanlah kita punya value di sini, di mana mass adalah 1.5, G 9.81, H1 is this one 0.3, sama dengan half 1.5 V square. So the speed will be equal to 2.43 meter per second. Okay, so this one kita pilih initial, this one adalah final. So that's question B. Now question C, we want to determine the maximum compression of X. This value for X here. So kalau kita pilih value of X, so this one obviously will be the final. So which one will be the initial? Any of this position lah, this one or this one sama saja, since hanya satu energy yang terlibat. So dua-dua pun akan sama. So now Miss akan pilih this one. Okay, so Miss akan pilih this one as the initial, this one as the final. So we want to find X. So initial tadi yang terlibat hanyalah kinetic energy, dan final potential energy untuk gravitational and elastic. So masukkan kinetic energy initial is equal to UG plus US. Then masukkan MGH, this one H2 lah, H2, oh sorry, bukan MGH, half MV square. And then this one MGH3 plus this one, masukkan saja formula tu dulu, half KX square. So this is what we want, value for X. Okay, and now value untuk H3 here. So H3, kami sudah labelkan this is H3, which is actually sama dengan X. Okay, tetapi H3 ni dia di bawah, okay, di bawah position di mana kita letak H sama dengan kosong. So kalau dia di bawah, dia kena letakkan sebagai negative. So H3 is equal to negative X. X ni still X. It doesn't matter because dia adalah compression, dia bukan displacement, dia bukan kedudukan. So H3 ni lah adalah the height, okay, the position. So that's why kita akan letakkan negative, sebab dia adalah di bawah position H sama dengan kosong. Value dia akan sama. So H3 will be negative X. So kamu akan masukkan half mass is 1.5. V adalah V yang tadi. And then G 9.81. H3 to negative X plus 1 over 2K. K tadi this value here. 200 Newton. 2000 Newton per meter. And then X square. So now kita ada dua X, satu X square. So kita akan dapat quadratic equation. Di mana kamu akan dapat 1000X square minus 14.715X minus 4.429 equal to 0. So this one selesaikan. You can either use calculator ataupun buat secara manual. So kamu akan dapat dua jawapan. Okay, kamu akan dapat dua jawapan untuk X. So satu positif, satu negatif. Okay, so soalan X ni dia tidak boleh jadi negatif sebab dia hanyalah compression. Okay, dia hanyalah compression. There is no positive, negative. So negative one kita tidak akan guna, dia akan jadi invalid answer. So this is what we want. This answer here is the correct answer.